Hello, everybody. How are you?
Good.
Good. And I really, really like interaction. I love it when you have your cameras on. I like when you respond to things. Thank you. And if I just feel like I'm spending an hour talking to myself, then I lose interest and I stop doing it. So I need questions and I need participation in order to make this work. So, my understanding is that y'all have a test on Thursday on the Moodle. It says the tentative date is October 30th, and I haven't heard anything since then. So I was gonna get started on the review today, but then I looked at the lab that y'all have, and I knew that y'all haven't done one like this before. So I knew that we would need to do some work for this lab. Um, One thing that is I'm a little nervous about is in previous semesters when I did this lab, I did it using the technique that y'all haven't actually learned in class yet that's really supposed to be for the next lab. And last semester, the professor told me, oh, wait, this lab, they're supposed to do it like they're modeling flip-flops. So I had not ever done it like using flip-flops before. And so I was trying to hastily write it this morning, and the code that I have is not quite working. And so I know that it's mostly right. We'll figure out what it is. Hopefully we'll figure it out during the course of the session. And once I do figure out what's wrong with it, I'll make sure I email y'all and let you know. Okay, so let's go ahead and get started. Are there any questions before I get going and we discuss the lab?
Nah, I was just confused because we've only spent one day on it.
Okay, yeah,
Like I
and it
struggle with actually drawing the diagram. I understand state tables.
Yeah, it is going to be rough at first. You'll get more used to it, but especially at first, especially this first lab, may be a little tricky since you haven't done a whole lot of them yet. Um, so anybody else have a comment or a question, like other than something specific, or how many of you have looked, how many of you have looked at the lab? A thumbs up or raise your hand or, uh, and so I'm assuming none of the rest of you have, or yeah, okay, some of you have, okay, all right. All right, so, um, let's take a look at it. You're supposed to be doing a sequence detector, and this is something that uh, is big in digital logic too. You can expect to see one on either your test or your final. I'd be surprised if you don't have one. So it's a sequence detector. The one I did last semester detected 111 or 010, and I have that one working, but it's using the more advanced method. So this one we're supposed to be choosing flip-flops and designing the next state function for the flip-flops. This you will need to know for your test. Usually what we're about to do usually shows up on the test. So pay attention to it. All right, so let's get to here. So um so we want a sequence detector that detects when the last three inputs, and I'm going to call them R because that's what I called them in my code. I don't think the lab specifies what to call them. The last three inputs are come on now. It's not gonna, there we go. Are 111 or 101. Um, Overlapping is allowed. What that means is if you enter 111, then you should detect. So you detect that. Well, actually, you detect it on the next clock cycle. So you detect here. So you have detect. And then if you enter another one, then you detect again because you still have that the last three were 111. And so you have to always pay attention to what you have and what you can get from that. So we are looking for 111 or 101. And with any of these sequence detectors, you want to think about what are my steps towards getting there. So our reset would be where you don't have anything towards a 111 or a 101. And that's also equivalent to also just having just a zero. If all you have is a single zero, that's not getting you towards either a 111 or a 101. So let's say that we have nothing or we just have a zero. And the next thing we input is a zero. Does that get us anywhere? Are we getting closer towards having a 111 or a 101? We're not. And so we would go back to this state. So if we get a zero, we go back to this state. If we get a one, however, that is getting us to a state that's different where I have a one. So if I have a one, then that's getting me towards a 111 or a 101. So that's getting me somewhere. So I'm just going to call that for right now. I have one, don't have anything else. Now, from this one, if I then get a zero, is that getting me towards a 111 or a 101?
Yes,
Yes.
somewhat.
Yeah. So I'm going to call that, I'll just say that right now, I'll just say I have a 1-0. Okay, if I get a 1, is that getting me anywhere?
Yeah.
If I get a, yeah, so that is also getting me somewhere, and it's somewhere different from having a single one. I now have 2 ones. Okay, so I get a 1, I now have 2 ones. Now, if I have a 1-0, so from my 1-0, if I get another 0, if I get 1-0-0, remember what we're trying to get is 1-0-1 or 1-1-1. So if I had a 1-0 and I get a 0, is that getting me anywhere?
No.
No.
So you gotta
No.
reset.
Mhm.
Yeah, it's not only not getting me anywhere, it's not even going to take me a step back. It's going to take me all the way back to reset because now I don't have anything. Now it's like just having a 0. But if I have a 1-0 and I get a 1, then that's good. That's what I'm trying to detect. So I know that's good. I have a 1-0-1. This means I will have an output because I've detected something. Anytime you draw a state diagram, what you want to do for each state is figure out what happens for all possibilities of inputs. Here we only have one input, so we just have to check what happens with a 0, what happens with a 1. But if you had 2 inputs, you'd have to check what happens for 0, 0, 0, 1, 1, 0, 1, 1. Okay, so now if I have 1, 1, if I have a 1, 1 and I get a 0, I haven't gotten to 1, 1, 1, but have I lost everything?
No.
No, because I still have this 1, 0 here. So if I get a 0, then I'm going to go to this state to where I have a 1, 0. So now I have a 1, 0, and I could travel along that path. Now, if I have a 1, 1 and I get a 1, then that's good. Now I have a 1, 1, 1, and I can output because that's one of the things I'm looking for. Now, this, have y'all talked about Mealy and Moore yet?
I don't
Okay,
believe so.
okay. So this is, we still have to figure out what goes on from here because we're not done. This is a continuous thing. So if I have a 1, 1, 1 and I get a 1, where do I go?
Would you just stop?
Well, I go back to the same, I go back to the same state
Okay.
because I had a 1, 1, 1. I get another 1. It's still true that my last three digits are 1, 1, 1. So if I had a 1, 1, 1 and I get a 0, what state am I going to be in?
You go to the right state, the 1-0 state.
I go to the 1, 0 state. So the way I have these written, I'm always looking at my last digits to see what I've got. You know, if I have a 1, 0, I'd go to the have 1, 0. If I have 1, 0, 1, I'd go to the have 1, 0, 1. Okay, now if I have 1, 0, 1, so if I have 1, 0, 1, and I get a 1, I no longer have 1, 0, 1 as my last digits, so I can't go there. I don't have a 1, 1, 1. I don't have a 1, 0, but I do have a 1, 1. So if I had 1, 0, 1 and I get a 1, then I can go to this state. And if I had 1, 0, 1 and I get a 0, well, I don't have my last three are not 1, 0, 1, but my last two are 1, 0, so I can go back to this state. So that is my state diagram. Now, generally, we'll have different name. We'll just call them A, B, C, and D. So let's do that. And y'all stop me if you see me make a mistake, because like I said, I don't, everything was not entirely working. So, okay, so from A, 0 took me back to A, and 1 took me to B. From B, 0 took me to C, and 1 took me to D. From C, 0 took me back to A, and 1 took me to F. And from D, 0 took me to C, and 1 took me to E. And from E, 1 brought me back to myself, and 0 took me to C. And from F, 1 took me to D, and 0 brought me back to C. All right.
So is A going to be 0, 0 and B 0, 1?
Well, we haven't decided that
Oh,
yet.
okay,
We'll
okay.
get there. Yeah, we'll get there.
Gotcha.
So next we're going to make a state table. So let me put that in. A, B.
Would the diagram with A, B, C, D, would that suffice for the create a state diagram?
Yes.
Okay.
I decided just to make it small. Okay, I'm just gonna write it. Okay. Um, Where's my stylus? Okay, so we're gonna have our current state. And we'll have our next state. And our next state depends on our input, if R equals 0 or R equals 1. And we'll have our output. Um, so our current state, if we have A, B, C, D, E, F, then our next state for A, and y'all watch me carefully on this, make sure I get this right. So if R is 0, that's A, and if R is 1 is B, and our output is going to be 0. Our output will only be 1 if we've detected the sequence. So that's only for E and F. E and F have output 1, and the others have output 0. Now for B, if we got a 0, we went to C, and if we got a 1, we went to D. And for C, if we got a 0, we went back to A. And if we got a 1, we went to F. And from D, if we got a 0, we went to C. And if we got a 1, we went to E. And from E, if we got a 0, we went to C. And if we got a 1, we went back to ourself. And from F, if we got a 0, we went to C. And if we got a 1, we went to D. Does that look correct to y'all?
Yes, I got the same thing.
Let's see if that matches what I have here. A, B, C, D. Oh, yeah, lovely. I called him something different on this sheet. Oh, well. Okay. Um, okay, so now what we need to do is what's called a state assigned table. And so we're now going to figure out how many flip-flops we need, and we're going to assign numbers to those. So you look at the number of states. So to determine the number of flip-flops, this is almost always a question on the test. And so it's an easy one if you know how to do it. So the number of flip-flops, the minimum number of flip-flops. So the minimum number of flip-flops is n, where 2 to the n is less than or equal to the number of states. So it's the smallest n. So it's the smallest n where 2 to the n is less than or equal to the number of states. So how many states do we have?
6.
We have 6 states. I need 2 to the n to be less than or equal to 6. And I want, I'm sorry, 2 to the n is greater than or equal to. Not less than or equal to, greater than or equal to. Greater than or equal to 6. And it's the smallest n for which that is true. Okay, so 1 doesn't work because 2 to the 1 is 2. 2 doesn't work, 2 squared is 4. 3 works because 2 to the 3 is 8, which is less than or equal to 6. So I need 3 flip-flops. If you see a question that asks about one hot encoding, then in that case, the number of states equals the number of flip-flops. That means you have 1 flip-flop for each state. But that's not what we want. That's not what we want here. I'm just letting you know if that shows up on a test, that's what that means. But for the minimum number of flip-flops we need is 3. Okay, so we're going to call these flip-flops I'm going to call them, I can't remember, I can never remember whether the book does the current as lowercase and the next as uppercase. I think it does the current as lowercase. So I'm going to call them Y2, Y1, y0. That's going to be our current state. And our next state, and we have two possibilities here. We have r equals 0 and r equals 1, and we'll call that capital Y2, capital Y1, capital Y0, capital Y2, capital Y1, capital Y0, and our output. Now, this is the state assigned table. And what we're doing is we are just changing out our letters for 3-bit binary numbers. I typically just go in order. So someone earlier asked me if A would be 0, 0 and B 0, 1. That would be true if we only had 2 flip-flops, but we have 3. So A is going to be 0, 0, 0. B is 0, 0, 1. C is 0, 1, 0. D is 0, 1, 1. E is 1, 0, 0. And F is 1, 0, 1. You don't have to do it that way. You can do it any way you want. But to me, that's the way that's going to make the most sense to me to keep track of what is what. And so all I'm doing here is I'm saying A is now 0, 0, 0, B is 0, 0, 1, C is 0, 1, 0, D is 0, 1, 1, E is 1, 0, 0, and F is 1, 0, 1. Now I use those same assignments to fill in the rest of the table. So here I had A is 0, 0, 0. So I have not been recording this. Oh no. Wait, did Zoom say I was recording it?
It said it was recorded. I don't know if it still is.
Okay.
Yeah, the top right, it says recording.
It's recording. Okay, so at least I have the Zoom recording. Okay. Okay, so now we're just replacing the state names with the letters that we came up with. So B is 0, 0, 1. And for B, we have C. C is 0, 1, 0. And D is 0, 1, 1. C goes to A is 0, 0, 0. And F is 1, 0, 1. Did C go to F? That doesn't seem right.
It shows on the diagram it
Yep,
does.
C went to F. Yep, yep. Okay. Um, D went to C, which was 0, 1, 0. And D goes to E, which is 1, 0, 0. E goes to C, which is 0, 1, 0. And E goes to E, which is 1, 0, 0. And F goes to C, which is 0, 1, 0. And F goes to D, which is 0, 1, 1. And our output remains the same. Okay, so now, and this is the part that I typically have people have the most confusion on. So now we have to figure out the equations for our flip-flops. So we need, and for our output, we need to figure out equations for Y2, Y1, Y0, and our output, which I'm just going to call S because that's what I called it in my code, S. Okay, so this, if you want to understand, I want you to pay attention here because this, like I said, this is where people tend to get confused. We're going to do Y2 first, and we're going to make a Carnot map. And Y2 depends on, so Y2 is the next state for flip-flop 2. And it depends on the previous state, and it depends on the input. So it depends on what Y2 and Y1 are, and also what Y0 and R are. So I'm going to have a 4x4 Carnot map, and the top 0, 0, 0, 1, 1, 1, 1, 0, that top is Y2, Y1, and the side is Y0R. And I'm looking at just Y2. So I'm looking at this column and this column. And the first column is when R equals 0, and the second column is when R equals 1. So these are the rows where R equals 0. So this row and this row is where R equals 0. And notice when R equals 0, Y2 is always 0. But notice something else. We are missing a couple states here. We don't have 1, 1, 0 or 1, 1, 1. So 1, 1, 0 and 1, 1, 1, those states are going to give us don't cares. And notice this is when Y2 and Y1 are both 1. That's this column right here. Those are don't cares. And now when R equals 0, Y2 is always 0. And so, and we determined that R equaled 0 in the rows where I put the red zeros. That's where R equals 0. And so Y2 is 0 in those rows. Now let's look at where R equals 1. So R equals 1 right here and right here. That's where R equals 1. And Y2 is the first column. So that's where R equals 1. R equals 1 right there. It's in the first column. And we see that we have 1s on C, D, and E. So C, D, and E. So right here, here, and here. C is 0, 1, 0. So 0, 1, 0, that's a 1. D is 0, 1, 1, 0, 1, 1, that's a 1. And 1, 0, 0, 1, 0, 0, that's a 1. Now let's check the others and make sure those are zeros. So A is 0, 0, 0, 0, 0, 0, is a 0. 0, 0, 1, that's a 0. And 1, 0, 1, 1, 0, 1, that was a 0. So here is my Carnot map for Y2. And so I want to come up with the best cover for Y2 I can come up with. And it looks like I can get that one and that one. So I get Y2 equals Y1 R or Y2 Y, those should be lower cases. Hold on. Y2, so the middle circle has Y1 equal to 1 and has R equal to 1. And this smaller circle has Y2 equal to 1 and has Y0 equal to 0 and R equal to 1. So y'all check me and see if that looks right to you.
Will we have to use the dunkers on the 1x4 instead of like just using 1-on-1, like 2?
Instead of using what?
So couldn't we just use 1-on-1, like a pair of 2, instead of having to use like with the dunkers?
So you have to have something for every state. So you have to have 110 and 111 in there, and using don't cares makes it easier than using ones or zero. I'm not sure what you're saying. If you're saying, can I just ignore those? The answer is no, you can't.
Okay.
You have to have something there, and the don't cares are the easiest thing to put there. You have to have 3 flip-flops, and if you have 3 flip-flops, then you have a total possible of 8 different states, and you have to account for all 8 states, even if 2 of them you're not planning on using.
Okay.
Okay. Did anybody see any? Oh, I see what you're saying. Could you like use just these ones instead of the whole don't care? You could, but
Yeah.
it's you could get it makes it harder because then you have an expression with 3 variables instead of just 2. In general, with a Carnot map, you want to minimize it, and you minimize it by having as big circles as possible.
All right. Thank you.
Okay. All right. Did anybody see anything I did wrong on that one? And if not, let's go on and do Y1. Okay, so I have another Carnot map. Y1. And this will be Y2, Y1, Y0, R. We'll have the same don't cares because it's the 1 1, the 1 1s that we don't have. And now we're looking at Y1, so we're looking at the middle column now. And so these are the ones where R equals 0. So that's this row and this row. So R equals 0. So I have a 0 for A, which was 0, 0, 0. And it had a 0 for C, which was 0, 1, 0, which is right here. And for everything else, I had ones. So let's just verify that. 1, 0, 0, that's E, and that had a 1. And then 0, 0, 1, that's B, that had a 1. 0, 1, 1, that's D, and that had a 1. And 1, 0, 1 was F, and that had a 1. So now we're going to look at when R equals 1, and that'll be our two middle rows. And we had a 1 for B, which was 0, 0, 1. So 0, 0, 1 is right here, and that was a 1. And we had a 1 for 1, 0, 1. That's right here. The others are zeros. So let's check. For A, 0, 0, 0, that was a 0. For B, we did that one. For C is 0, 1, 0. That was a 0. 0, 1, 1 is D, and that was a 0. And 1, 0, 0 is F, and that was a 0. Okay, so there's our Carnot map for Y1. And it looks like we get, so I can get this group, and I can get that group, and then I've got that one up there on top that I'll get, I can get it like this, wrapping around like that. Okay, so Y1 equals that bottom row, which is Y0 R bar, or, and then the ones that are wrapping around on the bottom have Y1 is 0, so that's Y1 bar, and Y0 is 1, so Y1 bar, Y0, or, and then wrapping around top and bottom gives me Y2 is 1, and R is 0, so Y2 R bar. So y'all please check me on that. Now, if you assign your state table differently, or if you gave different letters to your state diagram, you wouldn't get the same thing, which is what I was saying when I did this earlier. I assigned the letters differently, and what I got was a lot messier. So this one is nicer. Did anybody see anything that I did wrong? Okay, don't see anything in the chat. All right, so now we'll do Y0. Like I said, this is often on the test, so you do want to make sure you know how to do it. So Y2, Y1, Y0 R, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And now we're looking at Y0. We still have don't cares here. When R equals 0, that's our top and bottom rows. I have zeros everywhere, so that's handy. And when R equals 1, I have zeros only at 0, 1, 1. And at 1, 0, 0. And everything else is ones. So let's see, A is a 1, 0, 0, 1, B is a 1, 0, 1, 0, C is a 1, D was a 0, E was a 0, 1, 0, 1 is a 1. Okay, so there is our Carnot map for Y0.
I have a question about a grouping.
Yep,
Could you group the on the third row, could you group the ones on the outside?
I could. Yeah, I could. I don't, yes, and that does make it, that's a better one. Yep, because that way I only need 2 groups. Good catch.
Thank you.
All right, so Y0 equals, that top group is Y2 bar, Y0 bar, R, and the group that wraps around is Y1 bar, Y0 R. So any questions on that? Okay, now again, these will only work if you assigned your states the same way. If you didn't assign your states this way, you won't get the same answer. Let's gather our answers together.
Excuse me.
Yeah,
So I have a little bit of a question on like how we're determining like how there's a 0 and 1 in the K map.
yeah.
I'm just not exactly sure what we're looking at to determine the 1 or the 0 inside.
Okay, so this is where a lot of people are confused, and I promise you're not the only one. The only thing I wish is that more people had spoken up sooner, because everybody gets confused on this. So I was thinking, I must be explaining everything great this year, but I'm sure I'm not. So let's take a look at it. So I have Y2, Y1 going across the top. So that's Y2, Y1 across the top, and Y0R over there. So Y0 and R. So Y2, Y1, Y0, that is the name over here. And then R is either going to be 0 or 1. So I started with saying we're going to look at when R equals 0. So when R equals 0, that's just this here and this here. So I'm only looking at the top row and the bottom row. And then I look at Y2, Y1, Y0 in my chart over here to figure out if, in this instance, I'm doing Y0. Y0 is the third number in this column right here. These are Y0. So when I am looking to fill out what goes in this box, that's when Y2, Y1, Y0 is 0, 0, 0, and R is 0. So that's A with R equal to 0, and that's 0. So when I'm looking to see what goes in this box, that's when Y2, Y1, Y0 is 0, 0, 0, and R is 1. So Y2, Y1, Y0 is 0, 0, 0, that's still A, but R is 1, that's this number right here. And so the any number in this K map, so like any part in this K map, like if I'm looking at this box right here, that box is 1 0 from on top and 1 1 on the side. That's Y2, Y1, Y0, and R. So it means Y2, Y1, Y0 is 1 0 1. 1 0 1 is F, and R is 1. That's this column, this group over here has R equal to 1. So I'm looking at F and R equals to 1, and I'm looking at Y0, so I'm looking at the last digit in here, and that was 1, and that's where that 1 came from.
I see. That makes sense now.
Okay, does that make sense? And does anybody else need me to clarify that, because it is confusing?
So one question. So where do the numbers in the next state come from? So like, where do the 000 in the like under the R0 come from, or the 0010?
Where did these come from?
Yes,
Where
ma'am.
did these come from? Were you here for the beginning?
Yes, ma'am. Just double checking.
Okay, so those came from, well, we first assigned letters to the states, and then we assigned numbers to the letters. So we said A was 000. And so everywhere where we had an A, we put 000.
Mm.
And so when we look at this, we have a 000 here and here, because that's where we had A's. We assigned B 001. So everywhere
Oh, okay.
we had a B, we put 001. Looks like there's only 1 over there. So we only have 1001 over here.
Okay, okay.
Okay, yeah, so it's a process, and you have to go through each step. You can't skip any step to get to where we are. Does everybody else see where that came from?
Yes.
Ma'am.
Okay, all right. Well, let me gather together what we have. Oh, I love it. Every once in a while, this computer decides it's just not going to paste. Like, you can copy all you want, but I'm not going to paste. No, I'm just not going to do it. All right. I cannot remember things for the life of me. Let's see. So y'all have this written down, right? Somebody tell me what Y1 is.
The equation for it?
Yes. Or tell me Y2 first. So yeah. Tell me
For
what,
Y2, we had Y1 R or Y2 Y0 bar ended with R.
A and Y1.
The Y0 R bar ORed with Y1 bar Y0 and or ORed with Y2 R bar.
A and Y0.
That's Y2 bar Y0 bar R ORed with Y1 bar Y0 R.
Okay, now the last thing we need to do is get our output. The output is going to be easier because the output didn't depend on the input. So the output we had was 1 just for E and F. So see, I still might not be able to paste. Let's see. Oh no, now it's pasting. Okay. Okay, so now this is gonna be easier because it's just gonna be 4 by 2. So this is S, our output. And it depends on Y2, Y1, and Y0. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. And these were still don't cares. And it was ones only for 1, 0, 0, and 1, 0, 1. That was E and F were the only ones that got ones. So 1, 0, 0 is right here, and 1, 0, 1 is right here, and everything else was zeros. And so S equals Y2, which is what I got last time. So S equals Y2. Okay, so now that we have that, I believe that's what you have to have for your pre-lab. But you also have to turn this into Verilog code. Okay, so let's see how to do that.
I'm pretty sure.
Oh, and I have something else that I have to tell y'all. This is important. Okay, so this is gonna have a clock. And so this is gonna be the first time y'all will have used a clock. And there is specific constraints that you need to use for a clock. We're not using a clock, we're not using like the built-in clock. You're gonna use a button or a switch for the clock. And I know this is on some lab handout somewhere, but I don't know where. But I'm going to give it to you right now. Let's see. I think I have it in my constraints. And anytime you do a clock, you can expect that there's going to be one warning that you're going to get when you compile that you're not going to worry about. It's going to have some warning having to do with the clock, and you don't need to worry about it. So this is what you need for the clock. Let's see if it is anywhere else. Not here.
Would it be on the document of all the constraints?
I'm going to check that next. No, that one, the one on the constraints, that's for using a real clock. So you actually don't want to use that one. So that one, yeah, you don't want to use that one. This one is in, It's right here. It's in the file that was with lab. I'll see what number it was in a minute. It's at the second to last page of using Vivado to program the Basis 3 board to use a button as a clock signal. Now this one right here is using U17. U17 is this button right here. I hate that button because it often like double clicks. It's not debounced. So I recommend either that you use a switch or you use, I'm going to stop sharing my screen for a second. There's this little module, and if you ask for it in the lab, they have it, and it plugs into on the board on the top left. It plugs into the top row there. And then it's the bottom right button, and it's a debounced button. It doesn't double click. I recommend that one, or to use a switch and just use the switch that you choose. But since it says on the positive edge of the switch, that means you need to turn the switch on and then off to get it to do a clock cycle. With a button, you just have to press the button once. Okay, so we have this on mine, J1. J1 is for using that little debounced button that I just showed you. If you used a switch, you'd put the switch in there. If you just copy it right off the handout, you would use that button that's on the board. I'm just warning you, it's really hard to do sequence detecting with that. Since I already have the constraints open, let me go ahead and see what other constraints we would need. We are going to need a switch for saying if something is 1 or 0, and we're going to need an LED to do an output. So let's go back to our list of constraints. And I'll just use switch 0, which is V17. And I will use, I'm going to copy more LEDs in case I want to use some for debugging. I'll copy the first 4 LEDs. But for right now, those are not LEDs. Those are LEDs. Okay, but for right now, I just want those and these. And this switch is going to be R. And this switch, for whatever reason, or this LED, I had it as a capital S. I don't know why, but just to do things the same way. All right, so now I will add design source. Okay, so I will have my inputs. My input is R and clock, and my output is S. Clock is also an input. And then I'm going to have reg. I'm going to have Y0, Y1, Y2, and then I'm going to have next Y0, next Y1, next Y2. I'm having those instead of my capital and lowercase letters because those would be too much for me to try to keep track of capital and lowercase. Okay, now whenever you have sequential logic and combinational logic, you want to do them in different always blocks. You want to do your combinational logic in one always block and your sequential logic in a different always block. So I'm going to have always at R. So when my switch changes, this is where I want to do my combinational logic. This is where I want to define what my next Y0, my next Y1, and my next Y2 are going to be. And I'm going to have, this is not considered good practice, but I don't know what how else to do it. I guess I could make them equal to 0 in the definitions, but I'm going to initialize them to be 0. I don't know if you need to do that or not, and I don't know if it would work just the same as putting equals 0 right here. I don't know. Okay, so Y0 is going to be what we had over here. Not Y2, not Y0, R. Or No, that was y0, yeah. Or not y1, y0. Y1 equaled, y'all can call these out to me so I don't have to be flipping back and forth. So what's y1?
I can read out y1 for you.
Okay,
It is y0 ended with r naught, or r naught ended with y2, or
hold on,
y0.
hold on.
Oh,
R not ended with y what?
y2.
Okay,
And that would be ORed with y0 and y1 not. And then
hold on a
y2.
second. Hold on a
Oh,
second. Okay, y2.
y2 is y1 ended with r, or y2 ended with r ended with not y0.
Okay, and then our next always block is going to be our sequential logic. So this will be always at pos edge clock. We're going to make s equal to s was equal to y2, right?
Yes, y2.
S equals y2, and we'll make y0 equal to next y0, and we'll make y1 equal to next y1, and y2 equal to next y2. Oh, S needs to be a reg. Okay, so let's save that. Save the constraints. And then we can open an elaborated design. So this was the error that I said that you were always going to get, or a critical warning message. And it's usually going to be about the clock. Constraint line 3, that's probably the clock. So we can see we have a bunch of logic. And you can see that it knew that these were D flip-flops. And we did have a lot of ors and ands, so that seems possible. All right, so now let's generate a bit stream. And while this is compiling, are there questions that I can answer?
I have a question about the Verilog code. Like whenever you're
Yes,
equaling like y2, y1, y0 to the logic expressions, why did you do like the less than sign with the equal? Like does it
the
make a difference?
non-blocking. Yeah, okay, I'll show you why. The way this particular file works, it's not as important, but what the non-blocking does is it means that it doesn't change it until you get to the end of the file. So let's say that I didn't have this next y0. If I just had y0 and I wanted to make y0 equal to all of this stuff, well, if I didn't use the non-blocking, it would change the y0 here. And so when it got to this line, it'd be using the new value of y0, which I didn't want it to use. Now,
Okay, okay.
I didn't, because of the fact that I'm using a different variable, I didn't actually need to use the non-blocking. But whenever I do sequential logic, I just use non-blocking because I find I make fewer errors that way. Because I don't need anything to change until I get to the end of, and like here, S is equal to Y2. I want S to equal to what Y2 is right now,
Okay.
because if we look at our state diagram, our state diagram, we want to get what S is when we're on these blocks, not when we go to the next block. So I want it to be based on what Y0 is when I'm right there. So that on
Okay.
that one, it really was important. On the rest of them, I'm not so sure it is.
So essentially the non-blocking is like on that line of code, that's what you want to equal only at that one time. So it doesn't basically put it somewhere else.
Right? It's when it gets to the end of the always block, then it assigns all of these that you had up here. It doesn't do it one at a time. So like if I had A equals 1, B equals 2, C equals 5, and I have A equals B plus C and B equals A plus C. If I do it just like this, then A would equal to 7, and then B would equal to 12. But if I do it like this, then A equals 7 and B equals 6.
Okay, I see what it's doing now. That makes sense.
Okay, write bitstream complete. All right. Open hardware manager. Open target, auto connect. And program device. Okay, so I've got this right here. And I think I use the switch at the end. So I have it at 1, and I press the clock button, and I shouldn't get anything. Press it again, I shouldn't get anything. Press it a third time, and I should get something. And I don't think I do, because I still have some error that I have not figured out. So I need to figure out what my error is, and I will email that to y'all tonight. I don't know what it is for the life of me, because I've done these a million times and I can't figure out what it is, but I will let y'all know. But the basics of everything is correct, and you've got your pre-lab correct, and I will let you know why this is not doing what it's supposed to do before tomorrow morning. So check your email, and I have to go because I'm about to tutor someone else, and I will see y'all later.
I have a quick question.
Yeah.
Will this be posted?
This will be posted. I will post it as soon as I can.
Alrighty. Thank you.
Okay. All right. Okay. Bye.
Bye.
Other questions?
Oh, thank you.
You're welcome.
Thank you so much.
You are welcome.